On May 6th, OpenAI open-sourced the networking protocol it uses to train GPT 5.5. It's called Multi-Path Reliable Connection, MRC, built with AMD, Broadcom, Intel, Microsoft, and NVIDIA over 2 years, released through the Open Compute project, already in production at the Oracle Abilene site and Microsoft's Fairwater supercomputers. The protocol scatters one transfer across hundreds of network paths, reroutes around failures in microseconds, and runs on the latest 800 gigabit per second interfaces. The problem. Why does this matter? Frontier model training is a synchronization problem dressed as a compute problem. Every GPU has to finish its batch before any GPU starts the next. Network jitter is no longer a tail latency concern. It's the bottleneck. Two specific failure modes. Network congestion. Traditional RDMA over Ethernet sends one connection down one path. That path becomes a bottleneck. One congested link slows thousands of GPUs waiting to synchronize. Hardware failures. At hundreds of thousands of GPU scale, link, switch, and NIC failures happen constantly. Standard recovery takes seconds. Each pause wastes massive compute. As OpenAI's own technical post puts it, network congestion, link, and device failures are the most common sources of delay and transfers. How MRC works. Two innovations. First, packet spraying. Instead of one connection saturating one path, MRC distributes packets across every available link simultaneously. No single link could become the bottleneck. The result is a flatter network topology that uses less power and tolerates congestion gracefully. Failure detection and reroute happen in microseconds. Training jobs continue without interruption. Second, SRv6 source routing. The sender encodes the exact path each packet should take. Switches stop making per-packet routing decisions. They just forward. Lower switch power consumption, deterministic latency, simpler control plan. And here's the lineage. MRC isn't a clean sheet protocol. It extends ROSI, RDMA over converged Ethernet, plus techniques from the Ultra Ethernet Consortium, plus SRv6, a composition of mature standards optimized for AI fabrics. The coalition. 6 companies, 1 protocol. OpenAI designed it and runs the first deployment. Microsoft co-developed and hosts Fairwater. NVIDIA's Spectrum X Ethernet was the first hardware to run MRC in production. AMD provided the programmable fabric foundation. Broadcom's Tomahawk switch silicon scales it. Intel covers NICs and SerDes. As OpenAI's workload lead, Greg Steinbrecher, put it, several players have their own in-house implementations. That fragmentation is bad for the networking industry. You want everyone's energy going in one direction. That's why it ships under an Open Compute project license. Why open? Why now? 3 reasons OpenAI gave away 2 years of networking R&D. 1. Compute crunch. AI is staring down a shortage. Even saving 1% of GPU time across the industry adds up to billions in effective compute. Open sourcing MRC lifts the floor for every training run, including OpenAI's own. 2. Break fragmentation. Without a standard, every cloud builds incompatible in-house protocols. A single open spec consolidates vendor R&D and accelerates Ethernet over proprietary InfiniBand. 3. Stargate needs this. Multi-gigawatt clusters can't run on legacy networks. Open sourcing the protocol ensures the supply chain can build to the spec. The philosophy, in one line, OpenAI is treating the AI fabric as a single fluid system, not a series of isolated connections. Verdict. 3 takeaways. For infrastructure teams, plan for Ethernet-based AI fabrics. InfiniBand was the default. MRC plus 800 gig Ethernet plus SRv6 is the open alternative. For hyperscalers, in-house networking R&D just got cheaper. Redirect engineering toward orchestration, not the protocol layer. For the ecosystem, OCP just became the AI infrastructure standards body. Expect more Frontier Lab contributions to flow through it. Bottom line, OpenAI just gave away the wire, because the wire is no longer the moat, the model is.